So just make sure you have this on your study sheet. So on page 21, I just want to add a few things. I do that quite often. I go back and just add a few things on page 21. So when it comes to scales, obviously it looks like this, but notice that it said no decimals. So sometimes I will give you, the question will give you something like this, 1.5 centimeters on the diagram, and it's like 20.1 feet in real life, right? You've got decimals there. You don't want that. So in this case, you see that they both just have 1 decimal. So I'll just multiply both of them by 10. That's our trick. And so that turns to 15 centimeters and 201 feet. So if that happens to you, that's the easiest way to do it. Morning, page 21. So if you have 2 decimals, what will you do? Times 100. It doesn't matter. Like, find the number that has the greatest number of decimals, right? So it could be that you have no decimals here and you have 2 decimals on this side. Multiply both of them by 100. You get rid of the decimal. That's your goal there. So that's what I mean by no decimal. So every once in a while that happens. No biggie. We just times it by 10, by 100, by 1,000, whatever the case. 10 is the most common, to be honest. So it doesn't happen very often, but then you know. Another thing that I want to bring to your attention is this part right here. Like if you focus on this little diagram here, knowing that if your scale factor is 65, that means it has been reduced by 35. I really want you to understand that. Okay? So maybe I'll just say, how did you get the 35 here? How did you get that? I just went from 100 and I took away 65, and that's how I came up. So everything has to do with the 100, right? To get the 35. And here, 120, that means that it was enlarged by 20%. Again, I went 120 minus 100 to get the 20%, right? That's how I got it. So the baseline, your baseline is always 100. What happened from 100? Did it go up? Did it go down? Okay. So how's that going to affect you? If the question says the scale factor is 120% or 1.2, then you just know that's the scale factor. Okay? But if the question says something new has been produced and it's been enlarged by 20%, your scale factor is not 0.2. Your scale factor is 1.2. It's kind of telling you, right, add 20 to 100 and then turn it into a decimal. So there's a difference. If it says flat out this is your scale factor, or if they mention that what something has been reduced by or enlarged by, right? So then you kind of have to do a little bit of extra work to come up with your scale factor. And if you're still not sure what I'm talking about, you're gonna come across that, and then we'll deal with it when we get there. So just some heads up. Oh, one more thing, sorry. These two are actually, they're exactly the same. It's just that I use the terminology diagram actual when it comes to pictures, blueprints, model. You know what, even a map, if you want to add the word maps, I use this terminology here. It's just easier for me to know which one is which if I use this. If I'm making copies or replicas, then I like to say, hey, this is the original, this is the new, okay? So just remember, other than that, we work them exactly the same way. And these are actually equations, right? So watch this. There are 1, 2, 3 components to this equation. So I could give you these two and you figure out k, or I can give you k and one of them and you figure out the remaining, right? So this is kind of like cross multiplying and dividing is going to happen a lot with either one of these, okay? And also know that if you have a scale, boom, you can turn it into a scale factor just like that, right? The diagram goes up, actual goes down in this case. So let's go to 22. I did a few exercises where we just turned our scale to a scale factor, right? So that's that. I'll leave it. And then we talked about this scenario here. Okay, so we had to figure out the scale. There it was. Then the scale factor, right? Scale factor. There it is. And once you know the scale factor, that is fixed. So this truck, right? Sorry, from the actual to here, everything will be affected by 7/150, folks. Everything. Let's turn that into a decimal real quick here. Just so you understand it. It's easier to see. 7/150 times 100. So this is the, I'll show you a nuance even for grade 12 already. If you were to round this to 2 decimals, right? This turns to 0.05, correct? Because the 6 bumps that to a 5. However, if the province or I ask you to state this as a percentage, you go back to your calculator, multiply what you see times 100, and then state it as a percentage. So this is 4.67%. Do you understand that part? So I basically go to my screen to get my decimal. I multiply what I have on the screen times 100, and then I round this to 2 decimals. So don't say 0.055%. You would only lose half a mark. It's not a big deal. But if you like 100%, then this is what you need to do. Does that make sense? Go back to your screen. That's what I always say. All right. Not necessary. I like to work with this, but sometimes this is much easier to answer certain questions. Okay. So C, determine the height of the truck on the diagram. So remember, a scale factor always tells you what happened to the actual to get to that. We move from the actual to that. So we know that is a reduction. I'm pretty sure you can tell already by now. So let's determine the height of the truck on the diagram. So C is right here. I'm going to answer that right here. I will use this formula. Diagram over actual. I'll use that. Can I add, I'm just going to add an H for height. H diagram, H actual. And you need to know at least 2 things. Do we know the scale factor? Yes, right, we already know it. Okay, so I'm going to plug that in there. It's okay to plug in a decimal there as long as you use all decimals. So I just prefer to keep it as a fraction if I know the fraction. And what else do we know on this side? We don't know this. The H of the diagram is unknown. Soon I'll turn that into an X because it's just too much work writing that all the time. And then the height of the actual is 10, right? 10 feet. So let's just, what happens here? You go to the side of the variable, start with the number. So you'll cross multiply like that and then divide. And this is not showing your work. Some students think, oh, that's showing your work. That's just a trick, okay? So I go 10 times 7 divided by 150. That would be the proper way of showing your work. And that's 70, right? 70 divided by 150, and that's 0.466. That keeps going. What is this in? What units am I in? Feet, right? Notice, like if you look back here, there are no units but feet. So that means that your answer is going to be in feet. And you're like, that's a strange way of answering. What would I prefer this to be? This isn't wrong, but you see how everything is in inches here on this side? So if I didn't say anything, you'd be done here. Round to 2 decimals, you're done. But if I asked you to answer that in inches, just take it a step further. You know that 1 foot has 12 inches, right? You cancel out the feet. And so you basically grab your calculator and just multiply what you have by 12. And there you have it. It's 5.6 inches. This is, I'm going to circle that answers C in my opinion here. Okay. And then D, by how much has the actual truck been reduced. So I'm already giving it away that it's a reduction. I could have asked you that. It's like, how do you know it's a reduction? K is less than 1. K is less than 100%. But by how much? We'll go like this. 100 minus 4.67. Okay. And did I get that right? Yeah. So that would be what, 95.37, right? $33? Yes, sorry. 33. Thank you. Friday, you got to pay attention. I told you that already, right? So you reduce the actual by 95% to get this. Obviously, this is not drawn to scale, right? This is not drawn to scale. Just keep that in mind. Is there anything else I need to tell you about before we move on? Okay, recapping. The most important part of this operation was right here. My pencil is hovering over it, the scale factor. Once you have the scale factor, okay, you can use this again and plug in your scale factor, and I could ask you for either one of these as long as I give you one, and then you just have one missing piece, right? And then you solve for the missing parts. That's how this goes. And I could still talk about the width of the trucks and stuff like that, but usually this is all you will see. Okay, so I'm gonna switch it over right away. Let's go to, I'm gonna ask you to do page 23 and 24, just to work on that a little bit. So for now, that's your task, to just work through these pages. Can you do that? Can handle it? Okay, read it, see what's happening, apply what I was showing you in the notes, and just take it from there. All right. So make sure you pay attention, put it away, distractions. So, 24. What's the most important thing before you solve for anything is find a scale factor. And I'm going to find a scale factor using those two, right? I know those two measurements. So K is, in this case, if this is the original, then this is new, correct? So it's always new over original. Always. So to find a scale factor, I'm going to grab the 5 yards and put the 14 inches below. And some of you are realizing, wait a minute, yards and inches can't have that. So let's do some converting here. 1 yard has 36 inches. I don't know if I gave you this one, but there's a longer way to convert, but you'll still get the same answer. And this gives you 180 over 14. Some of you are reducing that, and that's fine, but this is my preferred one to use to solve for unknowns, okay? Everything from here to there has been affected by this. Okay? So now if you want to solve for x, let's say, use the scale factor again. We go 180 over 14 is equal to, which one goes with x? It's this one here, correct? Just put them in the right place. What always goes on top? New, right? 3.5 yards over x, like that. What's your answer going to be in? It's going to be in yards. Okay, because that's those are the only units that appear here. So how do you solve this? You cross multiply like this, and you divide like that. So it's 3.5 times 14 divided by 180. And that gives you, you will look at my key later. I'm doing this a little differently here. And that is 0.27 0.22 yards, correct? So if you wanted to round this to 2 decimals and just say 0.27 yards, that's technically correct, but everything in the original is in inches. So it wouldn't hurt to just go 1 yard has 36 inches. Okay, to cancel that out. So I'm just going to multiply that by 36. So that's 9.8 inches. So some of you were perplexed by getting this answer here. You're not wrong. I would just say this is the best answer. Okay. And y the same way. Okay. If you solve for y, we use the scale factor one more time. You just have to be careful. Y is up here, matches with the 11. 11 corresponds to the original, so I'm going to put that down here. Y goes up there. So placement is very important. And some of you will catch it if you get a weird answer, you realize can't be. So y is simply 11 times 180 divided by 14. So that's 141.42 and something inches, because those are the only units that appear. And so if you want to turn that into yards, this is going to work. 1 yard has 36 inches. Cancel that out. So you basically divide by 36. So this would be 3.93 yards. Okay, is the answer for y. So again, what's the most important thing before you do anything is find your scale factor. Sure, you can divide. I don't mind you still doing that, right? 180 divided by 14. The scale factor is 12.86 if I asked you to state it as a decimal. If I asked you to state this as a percentage, it's 1285.71 percentage. Okay, so that stays the same. So the pop can is also done similarly. Scale factor is given. If you see percentage, maybe keep it like that. Put it over 100 and use this to solve for the unknown. Okay. Do you remember the math trick? So if you divide anything and you go math, enter, enter, if it's possible, if it's not possible, it's not going to do it, but it will turn it into a fraction. So oftentimes if you see me putting a fraction, that's what I did to get there. But it's not crucial most of the time. Okay. All right. So finish 24 as well, please. And then it's 25 to 27. You should be basically done this. Put an arrow on 27. 27 is a scale diagram. You need to know how to do a scale diagram. There's a QR code on that page. And it's like, I know the whole lesson is like 40 minutes, but it actually jumps right to the end, the last 5 or 6 minutes, that's it. So I'm going to leave that up to you as part of your homework to make sure you watch that 5 to 6 minute video. If you don't know how to do scale diagrams, have you done scale diagrams before? IPR, I don't think so. It's actually not too bad. You just have to actually use a ruler for it, okay? You're gonna turn it into centimeters, and I'll show you on that video there. So make sure you do that, okay? Remember, work hard.